We can use a KSP value to determine the solubility of a sparingly soluble salt. In this problem, the salt is calcium phosphate. The equilibrium between calcium phosphate and its ions in water is this. Calcium phosphate dissolves to give 3 calcium ions and 2 phosphate ions. The KSP value for this, like any other equilibrium constant, is concentrations of products raised to their stoichiometric coefficients divided by those of the reactants, but in this case the reactant is a solid. So the KSP value looks like what's presented here. We can set up an ice table. The calcium phosphate is a solid. For every mole of that dissolves, we'll make 3 calcium ions and 2 phosphate ions. So the calcium will go up by 3x, the phosphate will go up by 2x, and at equilibrium then there will be 3x moles of calcium per liter and 2x moles of phosphate per liter. This is an easy problem to solve. Since the calcium ions concentration is 3x, and since the phosphate ions concentration is 2x, then KSP equals 3x all cubed times 2x all squared. Don't forget to put the brackets around the 3x and around the 2x. And when you do the math, that works out to 108x to the 5th. Solving that, we find that x is 1.1 times 10 to the minus 7 moles per liter. And don't forget that that's the number of moles of calcium phosphate which dissolved in 1 liter of solution in the first place. So the mass of calcium phosphate that dissolves in 475 milliliters of water is that molarity times 0.475 liters times the molecular weight of calcium phosphate. That works out to 16 micrograms.